Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to discuss the second unit of MDCAT course, and it is work, power, and energy. And in this unit, we will be discussing the topics of work, work done in gravitational field, conservative field, non-conservative field, energy, different types of energies and their formulas, conversion of energy from one form to another form, and how we can determine a particular quantity like speed and height from the conversion of energy, and then we will discuss the topic of power, escape velocity, two MCQs. So let's start the first MCQ, that is question number 101. Which of the following is an example of work done against force? So work done against force is walking on a flat ground. अगर एक आदमी फ्लैट ग्राउंड पर वॉक कर रहा है तो ऑब्वियसली अगर वो फॉरवर्ड फोर्स लगा रहा है और फॉरवर्ड फोर्स लगा रहा है तो डिस्प्लेसमेंट भी सामने हो रहा है. अब इसमें फ्रिक्शन भी हो सकती है इन्वॉल्व, बैकवर्ड ये अगेंस्ट फोर्स वर्क डन हो सकता है, बट इसमें क्लियरली हमें पता नहीं चल रहा कि किस फोर्स का जिक्र कर रहा है वो. गेटिंग डाउन विद द स्टेयर्स, तो इन दिस मूवमेंट फोर्स नीचे लग रही है, डिस्प्लेसमेंट भी नीचे हो रहा है ड्यू टू ग्रेविटी. ड्रॉपिंग एन ऑब्जेक्ट सेम लाइक ऑप्शन सी. So getting up with the stairs, this is the right option, I think, because when you are getting up with the stairs, you are moving against gravitational force. So answer is A. Work is independent of. The formula of work is FD cos theta. It is independent of time. Question number 103. A light body and a heavy body have equal momentum. Which one has greater kinetic energy? So what you need to do, you just need to memorize the formula in which kinetic energy and momentum are related, and it is p square by 2m. And in this formula, for the greater kinetic energy, the body must have small mass. So the lighter body will have greater kinetic energy because momentum is constant. Two bodies of masses 2m and 1m have their kinetic energy in the ratio 8:1. Then ratio between their momentum will be. So the formula of momentum is 2m kinetic energy square root. So the ratio of masses 2m and 1m. So the ratio of masses is 2:1, and the ratio of kinetic energy is 8:1. So we will multiply these and take square root. 8 2s are 16, 1 1s are 1. So answer is 4:1. C is the answer. 105 mathematical form of work energy principle is work done equal change in kinetic energy. So it's FD equal 1 by 2 mvf square minus 1 by 2 mv. C is the right offer. Work done equal change in kinetic energy. This is the work energy. 1 megawatt hour is equal. अच्छा, अब हमें ये पता है कि 1 kilowatt hour जो है वो 3.6 पावर 6 जूल के इक्वल है. तो मेगा करने के लिए इसको किलो होता है ना, वो 10 पावर 3, तो मेगा 10 पावर 6 होता है. So you have to multiply 10 power 3 on both sides. So when you multiply 10 power 3 on both sides, it becomes 1 megawatt hour, and 3.6 into 10 power 6 into 10 power 3, it becomes 3.6 into 10 power 9 joule. So D is the right option. So students, its answer is D, 107. When we come to the question 107, when the speed of moving body is doubled, so its kinetic energy is doubled. This option is wrong because kinetic energy becomes 4 times. So because in the formula of kinetic energy, there is square on the value of speed, that is 1 by 2 mv square. So when speed is double, kinetic energy will increase 4 times. Uh, its acceleration is doubled. It depends how much force is applied on a body. Acceleration does not depend upon velocity. It depends upon the applied force. Potential momentum is doubled. I think this is the right formula because the formula of momentum P equals mv. So there is a linear relation between momentum and velocity. So when velocity is doubled, momentum will also be doubled. 108. A person is holding a bucket by applying a force of 10 Newton. He moves horizontal distance of 5 meter and then climbs the vertical distance of 10 meter. Find the work done by him. So the work done by the person will only be the work done when it moves upward, when it climbs up a distance of 10 meters. Because when the person moves horizontally, the gravitational force will be acting downward. So walking horizontally, there will be no work done. So when we calculate the work done by the person when he climbs up, it is FD. It is 10. The force is 10 and distance is also 10, vertical distance. So answer is 100 joule. What happens to its potential energy when an object is taken to the high altitude? Its potential energy increases because the formula of potential energy is mgh. So when a person moves at high altitude, height increases, so potential energy also increases. The spring will have maximum potential energy. So the elastic potential energy, EPE, elastic potential energy is equal to half kx square. So when the spring is compressed or pulled out, in both cases, extension increases. So answer is C. Triple one. The work done in moving a body of mass m upon inclined plane is. So in fact, when a body is pushed in an inclined plane, there may be two work done. One due to this applied force, and the distance covered is L. So the one option is the distance may be F into L, but there is no option. So the examiner just wanted to ask the work done against gravity, that is mgh. So A, this is A. When this block is pushed upward, it gains height. So this height, so it is mgh. 112. Energy time graph is shown in figure power. So power is the work done over time, or you can say slope of energy time graph. So there is a straight line. So in this straight line, slope is zero, no power is delivering. So up to 5 power is being delivered, so its slope is 5 by 1. So answer is 5 watt. B is the right option. Work done by central force is, it is zero, because when an object rotates in a circular path, its displacement can be determined by a tangent line, and the centripetal force acts towards the center. So the angle between them is 90. So the formula of work is FD cos 90. So work done will be zero. A 2 kilogram mass is uplifted by a machine to a height of 200 meter for 10 seconds. Calculate the power. So the formula of power is work done over time, or it is mgh over time. So it is 2 multiplied by 10 multiplied by 200 divided by 10. So it's 400. B is the right option. Kinetic energy of body is 1000 joule. Its momentum decreases by 50%. Then kinetic energy comes. So first of all, we have to find the decrease in kinetic energy, and there is a shortcut. By that you can find the decrease in kinetic energy. It is 2p minus p square by 100. So it is 2 into Momentum is decreasing by 50%. You put the percentage here. 2 into 50 minus 50 square over 100. So it becomes 100 minus 25. It is 75. So kinetic energy decreases by 75. So when 1000 decreases by 75, the new value becomes 250 because 75% of 1000 is 750. In the question, kinetic energy of that body becomes means new kinetic energy is asked. So kinetic energy decreases by 750. So when we subtract 750 from 1000, the answer is 250. So answer is D. Electron, proton, deuterium, and alpha particle have same kinetic energy, which has larger momentum. So momentum and kinetic energy are related by this formula. You can clearly see momentum and mass are directly proportional. If kinetic energy is same, then the particle will have more mass, or massive particle will have more momentum. So its answer is alpha particle, because alpha particle is heaviest among all these four options. 117. An automobile of mass m An automobile of mass m is at the top of inclined plane and log is released and rolled down, effect with the friction, then work done. So automobile is moving downward. So at the top, the input energy is potential energy. And when it rolls down, the potential energy transforms into kinetic energy and work done against friction. So the answer is C. Because the friction will act upon this distance. So it would be F into D. The frictional work done against friction will be F into D, not F into H. So answer is C. Two trailers X with mass 500 and Y with mass 2000 are being pulled at the same speed, the ratio of their kinetic energy. You know the formula of kinetic energy is 1 by 2 mv square. If speed is same, then kinetic energy will be the ratio between their masses, because 1 by 2 and v square will be cancelled as they are same. So mass of X is 500 and mass of Y is 2000, so it becomes 1 by 4. Y to X, it is I just found X to Y. For Y to X, it becomes 4 by 1. You will invert it. So answer is C. If power of 1 kilowatt is maintained for 1 second, then work done will be. So the formula of power is work done over time. 1000. Sorry, we need to determine the energy, the work done. So work done is equal to power into time. Power into time. So power is 1000 watt because it is 1 kilo. And time is 1 second. So it is 1000 joule. That is 10 power 3. A force of 2I has moved a point from application to work done. So the work done is F dot D. So the force is 2I plus J. And now you have to take a dot product. You have to find the displacement. Body is moving from 3 point to 6.5. So you will subtract these values. 6 minus 2, it is becomes 4I plus 5 minus 3, 2J. Now you can take dot product by simply multiply I with I and J with J. 2 into 4, 8 plus 1 into 2, 2. So the answer is 10 joule plus 10 joule. A 6 kilogram, I'm going to erase it. A 6 kilogram block is released from rest 80 meter above the ground. When it has fallen 60 meter, its kinetic energy its kinetic energy approximate. So first you have to find the speed by this formula, 2gh, and in this formula height h is the height of fall. It is not the total height, it is the height by which the object falls. So it is 2 into 10 into 60. It is under root 1200. And now you have to find kinetic energy. So it is 1 by 2 mv square. So 1 by 2 into 6 into 1200 square root square. It will be cancelled. 2 3s are 6. So answer is 3600 joule. That is around beta. Two bodies weighing in the ratio 4:5 goes up. Let me erase it. Two boys weighing in the ratio 4:5 goes upstairs, taking in the time ratio 5, boys ratio 4, the ratio of their power. So the power is work done over time. So the work done is mgh. So their weight is in ratio 4:5, and time is inversely proportional to power. So you will take inverse of the time. You will multiply it. 4 into 4, 16. 5 into 5, 25. So answer is 16:5. Work done on a ceiling fan by gravity is zero because it is not moving. It is not, because work done due to gravity is mgh, so it is zero. Because in the work done there should be some displacement. One 24. An object is displaced from point 011 to 143. Find the work done. Let me erase it first. So first of all, you have to take dot multiplication of force into displacement. It is I plus 2j plus 3k dot, what is displacement? You have to make displacement 1 minus 0, 1i plus 4 minus 1, 3j plus 3 minus 1, 2k. And I previously discussed, you just need to multiply same factors, that is 1 into 1, 1 plus 3 into 2, 6, 2 into 3, 6. So it's plus 13 joule. The answer is 3. Which of the following type of forces cannot do work on the particle at centripetal force? We have already discussed this MCQ. The relation between horsepower and watt. 1 horsepower is equal to 746 watt. These are the just knowledge-oriented questions you have to memorize. These values. A man lifts vertically a weight of 40 kilograms to 1 meter in 10 seconds. A child lifts vertically a weight of 10 kilograms to 1 meter. So man does more work done. You can calculate it by the formula mgh. Work done by friction. Work done by friction increases kinetic energy of body, decreases kinetic energy of body, decreases potential. Work done by friction, I think due to friction, the body is dropped from certain height. Suppose its energy is 100 joule. So when there is more friction, then kinetic energy of body decreases. Because speed becomes slow, you can say the energy transforms into the work done against friction, so the body will get slower. That's why when the speed of body decreases, kinetic energy becomes small. So the answer is B. 129. A car travels with constant speed of 15. The car engine produces 4,000. How much power? So the power is F dot V. Just multiply these two values, 4,000 into 15. It's 60,000. That is E. If you lift a heavy book from the floor of the room and keep it in the bookshelf having weight height 2 meter, work done will depend upon because the work done will be MGH and it depends upon the weight of the object and the height of the shelf. So answer is because work done is equal to MGH because when you are lifting the body. So when you lift the body, the work done appears in the form of potential energy. So it depends upon the weight of the object and height of the object. If force and displacement of particle in the direction of force are doubled, work done would be 4 times. Because work done equal Fe. So when both are double, so 2 multiplied by 2, it becomes 4. If the kinetic energy of body of mass 2 kg is 25 joule, its speed is. So the formula of kinetic energy 1 by 2 mv square. So kinetic energy is 25 and the mass is 2. Now you will take square root of this value, then 25 square root will become 5. So answer is C. A force of 20 Newton acts on the body for mass 30 kg if the velocity is 50, the distance traveled by the body. So you can find it by work energy principle. That is F into D equals 1 by 2 mv square. Mass is 30. Velocity is 50 square. And the force is 250. And you need to determine D. You can take 50 twice to solve it without calculator. 50 5s are 250. 5 10s are 50. 2 5s are 10 and 5 30s are 150. So answer is 150. Oh, but there is no 150 here. You can take nearest option, that is D. Maybe. Now the question 134 is if the direction of motion of force is perpendicular to the direction of body, the work done will be 0 because the angle becomes 90. A load of 50 kg is pulled upward by 5 meters. Then the work done by the external force. Work done by the external force. If you are lifting the body, you are applying force upward and body is also going upwards, so the angle between them is 0. So it is 50 is mgh. You can take this formula. Mass is 50, g is 10, height is 5. It's plus 2500. If you consider it against gravity, then it would be minus 2500. An object of mass 1 kilogram has potential energy 1 joule to the ground when it is at the height of. Again, you will apply this formula. 1 joule equals 1 into 10 into h. So height would be 0.1 meter. A stone of weighing 1 kilogram is dropped from the rest to the height of 4 meter above the ground. When it has fallen 1 meter, total energy. So at the highest point, its potential energy is mgh. Mass is 1, g is 10, height is 4. It is 40 joule. And it is the total energy. So when it is dropped, the total energy remains same. So answer is 40 joule. Total energy does not change. Only potential energy and kinetic energy changes. When arrow is released from its board, the energy transforms from elastic potential energy to kinetic energy. A body of mass m thrown vertically upward attains a maximum height. At what height will its kinetic energy be 75%? Its kinetic energy will be 75% when the potential energy loses 25%, because 75 plus 25 becomes 100%. And 25% is 0.25, and you will get this value by h by 4. You can solve it without calculator, without doing any mathematical work. You can solve it by simple logic, because when you throw a body upward, its potential energy decreases and kinetic energy increases. So, sorry, its kinetic energy decreases and potential energy increases. Its kinetic energy remains 75% only when the potential energy remains 25, and it is on the h by 4, because 1 by 4 is 0.25, and when you will take percentage of it, 0.25 multiplied by 100, it becomes 75%. So the answer is C. 140. Which of the following is not a unit of power? That is joule second, because joule per second is power, joule second is not power. Which of the following is incorrect? Joule is Newton. ये गलत है, because joule is Newton per meter, not Newton. A motor having an efficiency of 0.8 uses 800 joule of electrical energy, the output energy. So the output is equal to efficiency multiplied by input. 0.8 multiplied by 800, it becomes 640. The law of conservation of energy explains that while work input is greater than work output for all machines, the missing energy must have converted into something like friction. A field will be conservative, then work done in a closed path is zero. 145. The diagram, the right simple pendulum with mass m swings to and fro the position B, the value of potential at position B. This is the mean position. At this position, potential energy is minimum, where kinetic energy is maximum. So answer is D. An electric motor creates tension of 4500 Newton in a cable and reels at 2 meters per second. The power is F dot V. You multiply it and it becomes 9000 watt or 9 kilowatt. Some of the students may pick the option 9000 kilowatt. It would be wrong, because it is 9000 watt, not 9000 kilowatt. All right. For constant force, the shape of the graph between power and velocity. For the constant force, this force is constant. Now power and velocity becomes directly proportional, and they are linear function. They have power 1, so there will be a straight line. An applied force accelerates an object from rest to velocity v. How much work is done by the applied force? How much work is done? Work is a form of energy. So its answer is C. Because when the object accelerates, it means it's gives kinetic energy, and according to work energy principle, work done is equal to kinetic energy or change in kinetic energy. Work done is negative if theta. I think the angle is asked. Theta. So for negative work done, angle must be 180 degree or pi radians. So answer is D. Which of the following is what? I think Newton meter per second square, because Newton meter is joule per second. Sorry, its answer is D. Newton meter per second, because power is work done upon time. So it is Newton meter and time is second. So answer is Newton meter per second. So we discussed all the MCQs related to work done in this test. तो आई होप कि आपको सारी बातें समझ आई होंगी. किसी क्वेश्चन में अगर प्रॉब्लम है तो आप मेरा ये नंबर है, इस पे आप कांटेक्ट करके मुझसे कोई भी क्वेश्चन जो है वो पूछ सकते हैं. इफ यू हैव एनी डिफिकल्टी regarding any test, any question, any topic, don't hesitate and ask the question. Okay? Stay blessed forever. Allah Hafiz.